In 1977, a group of geologists descended to the bottom of the Pacific aboard the submersible Alvin, operated by the Woods Hole Oceanographic Institution. The mission was straightforward: investigate temperature anomalies detected near the Galapagos Rift, about 8,200 feet below the surface. They expected to find a desert. The deep ocean floor was, at that point, considered one of the most barren environments on the planet. No light, no heat, no energy. The scientific logic of the time was simple. Without photosynthesis, there is no food base. Without a food base, there is no complex life. It was an axiom, a certainty. And then Alvin reached the bottom. Chimney-like structures rising up to 10 stories from the ocean floor, expelling columns of black superheated water, and surrounding them, dense clusters of life, giant mussels, worms inside white tubes with red plumes swaying in the hot current, crabs moving between mineral formations. Nobody was prepared. A supposedly nutrient-poor seafloor 1.5 miles down, and there it was, one of the densest ecosystems ever observed. Since that expedition, more than 500 hydrothermal vent fields have been identified around the world, every single one of them carrying the same question the first one raised: how is this possible? The answer starts inside the Earth itself. Where tectonic plates pull apart, the ocean floor cracks open. Seawater seeps into those fissures, travels miles down into rock heated by magma, absorbs minerals and gases, and returns transformed. What rises back up is no longer seawater. It is a superheated mixture of hydrogen sulfide, methane, and chemical compounds that would be lethal to most known organisms. When that mixture meets the cold water of the deep ocean, the dissolved minerals precipitate, solidifying at the edges of the opening and building hollow structures that grow continuously. Those structures are the chimneys. The so-called black smokers expel fluids at temperatures exceeding 400 degrees Celsius, hot enough to melt solid metal. White smokers operate at lower temperatures, carry different minerals, shelter different communities of life. In both cases, something lives there. The environment surrounding these chimneys concentrates everything science once used to define uninhabitable: extreme pressure, permanent darkness, toxic chemical compounds, temperatures ranging from near freezing to the melting point of metal, sometimes within just a few meters of each other. There is no sunlight. There never has been. And yet down there, a living system exists. Complex, dense, and completely independent of the sun. How? Plants capture light and convert it into energy through photosynthesis. Animals eat plants. Other animals eat those animals. Every food chain in every known ecosystem was anchored at some point to that same source: solar energy. The hydrothermal vents broke that premise completely. Instead of light, bacteria and archaea use energy released by chemical reactions, specifically the oxidation of hydrogen sulfide, a toxic compound expelled by the chimneys, which, when it reacts with oxygen in the ocean water, releases energy. That energy is then used to convert carbon dioxide into sugars, into food. The process is called chemosynthesis, and it was observed for the first time as the foundation of an entire food chain during that 1977 expedition. It changed everything. There is one detail, though, that makes this process even more remarkable. Many of these bacteria do not live freely in the water. They live inside the bodies of other animals in symbiosis, providing energy directly to the host while the host provides access to the chemical compounds they need. A partnership built in hell. The most visible result of that partnership has a name: Riftia pachyptila. The giant tube worm can exceed 5 feet in length. It lives anchored to the chimney walls inside white tubes, with a scarlet crown of gills extended into the hot water. It has no mouth, no stomach, no digestive system of any kind. It survives entirely through the chemosynthetic bacteria living inside its own body, bacteria that convert the toxic compounds in the water into nutrients absorbed directly by the organism. It reaches nearly its full size in under 2 years, one of the fastest documented growth rates in the animal kingdom, in an environment where almost everything is scarce. An animal that has never eaten anything in its life and grows faster than most organisms in nutrient-rich environments. But the tube worm is not the most disturbing creature living here. That title belongs to the Pompeii worm. Alvinella pompeiana was discovered by a team of French marine biologists in the Galapagos in the 1980s. It is a type of bristleworm that lives on the actual walls of black smoker chimneys, one of the most thermally extreme environments inhabited by any known multicellular animal. The tail end can be exposed to temperatures of up to 80 degrees Celsius. Meanwhile, the head end experiences much cooler temperatures. The animal lives literally on the boundary between tolerable and impossible. It was named after the city of Pompeii, destroyed by the heat of Vesuvius in 79 AD, a worm that survives where an entire city did not. Around all of this, the ecosystem expands. Giant mussels of the species Bathymodiolus are often the first organisms to colonize a new hydrothermal vent, capable of surviving for a short period even after the vent becomes inactive. Crabs move between the formations. Octopuses hunt at the edges of the thermal field. Shrimp cover the chimney walls in dense layers. And then there is the Yeti crab, Kiwa hirsuta, covered in hair-like structures called setae that grow across its entire body. These structures shelter colonies of chemosynthetic bacteria that the crab actively cultivates, waving its claws rhythmically to keep the bacteria well supplied with chemical compounds from the water. A crab that farms its own bacteria on its own body. More than 300 new species have been discovered around hydrothermal vents since 1977, each one representing a different solution to the same problem: how to exist somewhere nothing should be able to exist. The answer evolution found, over and over again, was the same: don't fight the environment, use it. This ecosystem does have one vulnerability though, and it reveals just how completely dependent everything here is on the source. When a chimney stops expelling fluids, which happens naturally over time, the entire ecosystem collapses. No chemical source, no chemosynthesis, no food base. Expeditions that returned to previously documented sites found only skeletons and remnants. An underwater city abandoned within the span of a few years. The same speed at which life appears is the same speed at which it disappears. For centuries, the definition of habitable had been built on criteria that seemed universal: access to sunlight, moderate temperature, absence of toxic compounds. Those were the parameters, the boundary of the possible. The hydrothermal vents eliminated every single one of those criteria, and life continued anyway. That forced science to reformulate a question that seemed settled: what does life actually need to exist? The answer that emerged was unsettling in its simplicity: energy and liquid water. Not necessarily light, not necessarily moderate temperatures, not necessarily the absence of toxins, just a source of energy, any source, and water in its liquid state. That reformulation opened a door nobody had seriously considered before. Some scientists propose that life on Earth may have begun around hydrothermal vents 4.5 billion years ago. In this hypothesis, chemical reactions in the primitive chimneys produced organic molecules, the building blocks of life, in an environment where chemical energy was abundant and liquid water was present. Researchers at NASA and the Jet Propulsion Laboratory simulated those environments in the laboratory. Under extreme pressure, fluids mixed with chimney minerals produced organic molecules, including formate and traces of methane, compounds that make up nearly all known life on Earth. The experiment showed that the conditions needed to create the building blocks of life existed naturally in the hydrothermal vents of the primitive ocean. The most disturbing implication of that discovery, though, is not about Earth's past. It is about the universe. Europa, a moon of Jupiter, has a liquid ocean buried beneath a crust of ice. Enceladus, a moon of Saturn, expels jets of water vapor and organic compounds into space, suggesting hydrothermal activity in its interior. Both of them carry the two ingredients that Earth's hydrothermal vents showed are sufficient to sustain life: liquid water and chemical energy. Such vents are also thought to exist on other worlds, such as Europa or Enceladus, and may provide habitable environments where life could emerge even in the absence of sunlight, concluded researchers from NASA's Astrobiology Institute. In 1977, a group of scientists descended to the bottom of the ocean expecting to confirm a desert. What they found was an entire ecosystem, dense, diverse, fully functional, that had no idea the sun existed. Since then, more than 500 hydrothermal fields have been identified. More than 300 new species have been described. and the definition of habitable has been rewritten in a way it will never recover from. If life doesn't need the sun to exist, if it can thrive in boiling water, in absolute darkness, under extreme pressure, fed by compounds that would kill any human being in seconds, the question stops being whether life exists somewhere else. It becomes something else entirely. Why wouldn't it?
If this video made you see things in a completely different way, then it was worth it. Now tell me, did you already know all of this? Or did something here surprise you? Drop it in the comments. I really want to know what you think. And if you enjoy this kind of content, make sure to leave a like. How? It really helps and shows you want to see more.